here, and the thing that says less than 10 is back, so you can scroll through, like a regular book.
Okay, so we're integrating with respect to y. Sometimes the bounds of a region are more easily described if we go left to right than up and down. So yesterday we talked about area between curves. We talked about top minus bottom. Now we're going to talk about right minus left. So the right function will be the farthest from the y-axis. So we're going to go from the y-axis to the function. Y-axis to function. So you're finding the area between the two with respect to y instead of being with respect to x. If I change and I'm doing with respect to y instead of with respect to x, what is the variable or constant of integration going to be noted now? Dy or delta y.
If we do right minus left on the left side of the y, or is it left minus right?
Like, so this one that goes over is still right minus left. Why? Because you go from the y-axis to the further one away.
Yeah.
So that would give you all of this area. And then you'd go from the y-axis to the closer one. So it would subtract away this, leaving you with what's in between.
Yeah, so what if it's on the second
That's what he was saying, if it goes this way. So if you went left, no, it'd still be right minus left. Because right would be here and minusing that.
Which would be adding in.
But it would all be negative because of the x bounds.
Yeah, but if you take a one that's to the left, so this is the negative one, right? This is negative because it's on this side of the y. And so this is the right one, this is the left one. You subtract this one from this one, wouldn't that make it less of a negative, which would be like here. So like the area here. If they're both negative, subtracting a negative would make this be like adding a positive, which would be like taking this and
I'd have to go find an example. I don't even have an example of one where it's all to the left. Like, I know what you're asking. I'd have to physically like create a problem and do it. Okay, go ahead and take a minute and graph your functions with respect to y instead of with respect to x. Like graphing with respect to y. I just drew it. Like you can, yeah, I was gonna say you have one of two things. You could either turn your whole paper and graph it like a parabola, where like this is y and this is x, so then you just flip your axes. Or you could try to solve for y. The problem with solving for y is you have to make sure when you do your square root, you don't lose the plus minus. You can also just like plug in numbers. Like you could plug in and say, okay, what happens when x is 1? What is y? Or y is 0, what is x? minus a minus, which makes it a positive 1. 1 plus 3 is
Oh.
4. Square root of 4 is 2. Positive or negative. So, once you have a graph, you'll notice that we don't really have a top minus bottom situation set up because what happens is the red becomes above the red. So you can't do top minus bottom when it's the same function. And I know we could take the idea and say, okay, well this is really like the positive square root and this is really like the negative square root. But now we're talking about integrating square roots, and that's pretty messy also. So what we're going to do is we're going to say, okay, the red function is always to the left. The blue function is always to the right. So we're going to take the red function in terms of y minus the blue function in terms of y. So our integral would be the red, which is 3 minus y squared, minus the blue, which would be y plus 1. So it's right minus left. Now, our bounds are usually the x to the x. It's going to be y to y. So they meet at y equals -2, and then they meet again at y equals 1. So your bounds would be -2 to 1, and we are integrating with respect to y, so the end would be dy. Now, the y is like an x in terms of power rules and all the mathematics that we do. So all you're going to do is clean this up. So you have 3 minus a minus 1, which becomes positive. So you get 4 minus y squared minus y dy. So you get 4y minus 1/3 y cubed minus 1/2 y squared, evaluating from 1 to -2. Okay? So you have 4 minus 1/3. Sorry. When I did this, minus a minus.
Is it 2?
It should be 2.
Okay.
I literally
I
was
was
just
really
like looking,
confused.
going like, wait,
I was like, where am I
write
missing
2?
a negative?
No. I'm just change your, you can totally change a 4 to a 2. Ready? Make your 4.
That's an ugly.
I can't even read that number. You know, if I wrote that on a test, you'd be like, I don't know what this is.
Yeah, we're gonna use all of these strategies on the test, and then your brain's gonna see them as the correct answer.
Is it a 4 or 2?
Which one's right?
That's right. That's the one I picked.
Okay. So,
Give me a minute to Google it.
come on. Combined like terms, so minus a minus became a positive 4 minus 8/3 plus 2. 4 plus 2 is 6. 6 plus 2 is 8. Negative 8/3 and negative 1/3 give you negative 9/3, and then minus a half. So what's nice about negative 9/3 is 9/3 becomes 3. So 8 minus 3 is 5. 5 minus a half. Find the area of the region R in the first quadrant that is bounded above by the square root of x and below by y equals x minus 2. So square root of x goes through 0, 0, 1, 1, 4, 2, and 9, 3. Y equals x minus 2, starts at negative 2 and goes up 1 over 1. Good? So, would we do this problem as top minus bottom or right minus left?
Could you do it as both?
Do it as either, right? So you could, so it's kind of not necessarily a trick question, but the area could be set up either way. So because I want to work on getting better at setting up our integrals, let's set it up both ways. If we set it up as top minus bottom, which is the way it's set up right now, because we're y equals, top minus bottom would be square root x minus x minus 2. We're evaluating in terms of x, and my bounds would be 0 to 4. Why would that create a problem? What's happening here? It's a negative. So you just have to be careful when you're setting it up, because you'll have to account for that little bit of negative that happens.
What do we do to account for it?
The fact that the blue curve, so when you do area under curve, it's from the curve to the x-axis. So since this is below the x-axis,
I just thought it was first period stuff.
no, we did that for Q, you took your break. And then all the picture stuff. Yeah. Yep.
Ours said that it's bounded below by the x-axis.
Right, that's what I'm saying. So how do you account for this being below it? Because it says it's bounded above,
So that equation ends
like it's in the first quadrant, so this is in the third. So what I'm saying is, how do we get rid of it? Like, see how this is, like, it bounds it to here?
Oh, okay.
So, like, the way that's set up right now, we're taking it and finding all this purple space. But the way exactly it reads, what are you supposed to be bounded by? So how?
On the x
so do you
Find
change
the
the
integral of the line split it to four.
Yeah, exactly. You'd have to split it to account for the fact that it wants only the first quadrant and none of this. Does that make sense?
So what did you do that? I was trying to line.
So the problem reads, find the area of the region in the first quadrant. So the way we have this set up, we were finding the purple. I want to eliminate the purple down below because that's not bounded by the first quadrant. So there is no blue line from here and over. So all I need is to bound this graph from the red to the x-axis, which is a normal area under a curve. So you have to split your integral so that it is only 0 to 2 for the square root of x, and then add to it 2 to 4 for right minus left. Yes. So this would be like the purple, and then this is the bounded by quadrant 1. What were you saying about Paige?
Paige is right, and she said we had to do both.
We don't have to do both, and that's why we're setting it up like this. If we did right minus left, it never goes down here. Because you bound it by saying y of 0 to y of 2. Like you want it go to the y, like because you're bounding it by y's. It is. Which is why this is in the integrating dy notes. But I want you to see all the connections. If we do it as dy integration, exactly, you can bound the quadrant 1 by making your integral 0 and not even having to worry about the black. So you'd go 0 to 2. The right one would be the linear aspect. So what you have to do though is you do have to rearrange this so that your equations are in terms of x equals, not y equals. So this would be x equals y plus 2. So it'd be y plus 2 minus, how do you get rid of a square root? Yeah, so it'd be y squared equals x. What part of the square root do I care about? Just the top. So, doesn't affect me too much for this because we're only plugging in the positives. So you'd have y plus 2 minus y squared, integrate it in terms of dy. And can you even just see taking the integral of a quadratic type function like this is going to be way easier than taking it of a square root? So now to find the area, you'd say 1/2 y squared plus 2y minus 1/3 y cubed from 2 to 0. And then you get to plug in a 0. We love zeros because they zero out. So 2 squared is 4. 4 divided by 2 is 2. 2 times 2 is 4. And we subtract 8/3. So 6 minus 8/3 is 10/3.
I'm really sorry, I have to wait, but so like that dy integration, everything above that, is that a separate method or is all that
Separate method.
Okay.
It's the squiggles. For sure. So it'd be 18 minus 8. You were really making me question my fractions for a minute. Okay. Example 8, find the area of the region between the curve for these two functions. Okay, so you have y equals 3 minus x squared. We know that that's going to look like a... Yeah.
Oh, sorry, I did the other one first.
Quadratic shifted up 3 and open down. Graph ends at 2. Oh, you'll be fine. This guy's gonna run in.
There's no 3 other row.
I'm just drawing an extra line.
Why'd you do that to us?
Yeah, it stops at 2.
Oh, you have to like go below your dots one, sorry.
It's okay.
Technically you don't though.
This one, what? Who won that? Is that really not a rightful one? Is that one? Wait, that's
y equals negative 1.
Yeah, it's y equals negative 1.
Negative 1, negative 2.
Okay? Because it's through the line y equals negative 1.
That's a fact. Big chunk.
So again, this is a problem you could do either way.
Oh, I messed up.
So you could do it where you integrate with respect to x's, and you could do it where you integrate with respect to y. If you do x, it's top minus bottom. So x would go negative 2 to 2. And top would be 3 minus x squared minus a minus 1 dx.
Why was it negative 2? Oh, never mind.
Okay. And then if you did it in terms of y's, your y's are right minus left. So what's the right function versus the left function? Remember, we have to rearrange this equation. So it would be y minus 3 equals negative x squared. Divide out your negative. So it'd be negative y plus 3 equals x squared. When you square root that, the positive would be the right, the negative would be the left. So when you do right minus left, it's actually going to be the square root function both times. Does that make sense? Your bounds would be negative 1 to 3. So right would be the positive side. Minus. No, in this case, you would take the x's. Again, it's showing you that all those problems can be done either way. Tomorrow, I will be leaving you a review from 7.1 to 7.2 of all the different problems that we've seen so far.